Hello everyone. Sorry, but we had some delay due to technical reasons, but thankfully we are here. Together with Abu Olavani and with Joshua John, we are about to talk about deploying computer vision models, but on edge devices. So the floor is yours. Without further ado, let's begin the talk. I keep
All
my
right.
fingers crossed.
All right. Thank you everyone for joining us today. My name is Abu, and with me here is Joshua, and
Hi,
we'll be talking about deploying computer vision models on edge devices. And I hope you enjoyed this presentation. So in this presentation today, we'll be talking about introduction and overview of computer vision and edge computing. We'll be talking about the different use cases, and also we'll be talking about like when you have to like choose your devices, what are the constraints you have to consider, and the challenges when we are deploying model on these devices. We have a demo for you and called Pack Vision, and also we are open to any question you have after the presentation. Thank you for listening. So here I will start with some brief overview of computer vision. Computer vision, when we talk about it, we are talking about like a technology that train computer to recognize images and describe them perfectly. And it depends on the data type that you use. It could be a video, it could be text, it could be image data. But computer vision has been used over the years for several tasks. One of them is image classification problem, which is the task of assigning a label to an image from a predefined class. And also we have classification plus localization. This is like when we want to identify the location of an object and then we draw bounding box around it. Also, we have object detection. Object detection has to do with, for people that are not aware, but when you have more than one images or objects in an image, we can start by saying, okay, we want to work on a computer, an object detection problem. But one thing that object detection does is it identifies the image and its location, and then the object detection system will return like the coordinates of the objects in that image that has been trained to recognize. And also we have like the confidence level, which show how confident the system is in making prediction. So when we talk about instant segmentation is almost similar to object detection and semantic segmentation, because instant segmentation we detect every distinct part of an image in an object and then segment them, also kind of produces a pixel perfect segmentation marks around it, as you can see from the images, and classify them. So moving forward, when we talk about edge computing, it's the recent or latest thing that has been going right now in the industry, and it has proven to be one of the best solutions that we can actually look into when we are talking about AI and the likes. So edge computing involves processing data near the data center rather than relying on a centralized server. Now, when we talk about cloud AI and edge AI, cloud AI involve when we want to like execute computational tasks that involve maybe pre-training of model or pre-processing of data sets. This require a huge amount of data, and it require a huge amount of compute capability. We can actually do this on the edge. We can do this in the cloud rather, and we won't have like any problem, so to say. But when we talk about edge, it's gaining attraction because we can deploy model directly and still make inferences on these edge devices. Now I will move to some of the application of computer vision. We've seen it over time that it has been useful in the healthcare industry. When we talk about autonomous cars, smart cities, smart home assist, we've seen this even in industry. In manufacturing industry, this has been proven to be one of the best application of computer vision. Now, when you are selecting an edge devices, there are several things that need to go into place to select these devices. And because they are resource constrained devices, we try to classify them into high-end devices and low-end devices. When we talk about, for an example, NVIDIA Jetson, it comprises of over 2,000 plus um, CUDA code and like 56 thereabout of tensor code, which makes it suitable for training of data and for making inferencing. So also with Google Cora, it has an edge TPU that we can easily like use it, though it's mainly for making inference, but with the capacity of what it could do, we can actually like use it to train. But when we talk about microcontroller, they have low computing power. That is why we can only use them for small tasks or small AI problem or solution that we want to use them for, and so on. Also, when we talk about STM32 series, they have low computing power. So when we want to deploy model on the edge, there are several constraints that needs to be considered, that needs to be looked, especially the business requirements, and then also the trade-off of, okay, are we looking into performance or are we looking into accuracy? Because these are important um, consideration to look into. So here we have a small flow chart that tells us about the deployment, or I'll call it deployment workflow of deploying model on edge devices. First, we know we have to like collect the data, pre-process them, and then the model architecture is also one important thing because you need to choose the right model. There are some models that are actually like designed for these edge devices. Some of them are like mobile nets, SSD, YOLO, and the likes. The list keep going. We have to train them, evaluate this model performance. And when it comes to model optimization, it is really important if we understand the constraint of this hardware that we are dealing with, because as a result, we can minimize the memory footprint of this model so that we can deploy them on this hardware. So when we are talking about optimization techniques like quantization, pruning, batching, these are really, really important optimization techniques that is viable and that helps us to be able to deploy this model on edge devices. For now, I would stop and Joshua will take us further.
Okay. Hello. So standing on existing protocol, thanks DSS for this opportunity, and then continuing from where my colleague stopped. So we have like various frameworks. If I may ask, is my screen visible?
Yes.
Okay, thank you. So we have like various frameworks and architectures, right, which supports edge computing. So for example, we have like TensorFlow, like the ONNX runtime, which was developed by Microsoft. So these inference engines help us when we train the model using the big system like our laptops or the server or whatever. We export them, we export the model file, and then with the help of this inference engine, we can run the model on our edge device, right? So this helps us, like for example, the demo we are going to show you now is an application developed on mobile phone, right? It's actually active on my phone here. Yeah, so I just put a screenshot so you can see. Yeah, so it's called Park Vision, right? The whole idea of this application is we gather the lot of images of a parking lot, of a sample parking lot. We annotated them, we trained them using Python and TensorFlow, and then so we exported the model, right? So we did what's called quantization. which is reducing the size of the model to a minimum size so that it runs easily on the application. So this is the app, Park Vision. What does this do? It captures, it looks for free parking slots and draws a bounding box around it. So I'm going to show you a quick demo so you see. So here is the demo, right? So to my left is on the, it was run on a Raspberry Pi, and to my right is on my mobile phone. So you can see, so it's just a quick one, let me play it again. So here you can see it running on a Pi, right? So this is just recording the frames that happens when detection. So during detection, this is real time. And also on my right, you see the feed from the mobile device, right? So I open the app, I select the frame, right? I detect the slots, and then it draws the bounding box. Here, the bounding boxes are not drawn properly because when it's on the app, it squeezes. So there is a coordination mismatch. So for me to address that, I then, if you click on the middle button, view slots right here. So these are the slots that are actually detected. So you see that it's working properly. So this is just to confirm. So basically, this is just a proof that edge device is, and you see how fast it is. So everything is done on this mobile device. The model, everything is implemented on the mobile device. And is locally. There's no connection to the internet and all. So this is one of the benefits of edge device. It gives us this great ability. Okay, so like I was saying before, the benefits of using edge devices, of edge computing on edge devices, right? So reduce latency, improve privacy and lower bandwidth usage. Basically, is everything we've been saying for like a couple of minutes now. Basically, you have your model stored on your phone, right? You have everything in-house. So when you are making inference, it's happening ASAP and you're getting your results in real time. So these are like the benefit of edge device. And then with this, there is no back and forth of data to the server. Hence, there is no security loop and there is speed. Everything works fine. But one of the disadvantage of edge device is, for example, I update my model. I want to do something better. I improved my model. I have to like deploy it again to the edge device. So the model maintenance can be an issue. Also, the storage constraint. My phone doesn't really have that much high storage capacity to handle models that require great storage use case, right? So also computational resources. For example, if I'm running object detection, there will be a little lag because if I have like 2 gig RAM mobile device or my Raspberry Pi is a 4 gig RAM, though you can see the lag, especially if the quality of the images and the pixel is very, very high. So these are like the few challenges and benefits of edge computing. So the future trends, what we can see now, we see due to great computing development, right? So we can see mobile phones now having 8 gig RAM. So this creates gives edge computing a really big boost, right? We can see now there's a Raspberry Pi version that has 8 gig RAM, right? And then we also have tiny devices with great computing uh, um, great computing great computing resources like storage, good memory, runs faster with good chips. So that's a good future trend for edge devices. And also with emergence of IoT and then 5G, so it means communication, maybe to download the model is going to be faster. It won't be a problem. So with this, you see that edge device is here to stay, and here to stay means it's going to change our lives in a better way. So here, if you have any feedback or any question, you can please ask now.
Okay, thank you very much. That was quick and concise. I would like to check. I have to check the chat window. No questions there or comments, but maybe there will be more. And yes, there is a question on the Slido platform. And I believe you do remember before we started talk, I've shared with you the URL to this event. And here we have the question. And we have another question here as well. So I will grab it. I will copy and paste it into the correct window. Okay, now accept. So if you please kindly take a look, uh, please check the chat, and there you will see the URL, and please activate the URL and check
Okay.
the wall. Okay, with these questions, of course, I will provide them as well. I'm gonna read them aloud.
Uh-huh.
Okay, so as far as I can see, we got 3 questions. Question, okay, I think I should start with
I
this
see a
one.
question by
You
Derek.
see?
Yeah. Yeah, I
Yes,
see it.
yeah, we can see.
If you see, that's great. I'm going to highlight the question and go ahead. So for edge vision models, how important is the launch of Copilot Plus laptops? Is Snapdragon X Plus a big improvement in this area? As data scientists, would like you to buy this machine to improve performance of your experiments.
Okay, so I will answer this, right? Copilot is an AI tool that helps make whatever you're doing better and faster. So yes, Copilot for vision model, Snapdragon, which is a chip on the mobile phone, like I said in the future trends, development of faster chips and high computing device, small devices. This makes edge devices a very useful, right? So you have a Snapdragon X, you're using Copilot on your laptop to make a program. So this is a good improvement, yeah. So as a data scientist, yeah, if you want, maybe you want to create an object device or object detection or probably image recognition. This here, what was made here was basically image classification, cropping the images and then running it against a model which is stored on the device, right, to make inference. So if you have a Snapdragon X chip device, and then Copilot is assisting you and solving your problems, yeah, this is a good idea. You can buy this device to perform your experiment.
Okay,
I
thank
hope
you
I
very
answered the
much.
question.
Yes, I think I should mark this as answered and the number and it was some number question number 2. What about security? What if someone will steal the model?
Okay, so I'll go with this. I'll answer this, and then my colleague will answer the last one. Yeah. So for security, so for deployment for production purposes, right? This edge device here that was stored here is passed over a secure channel. So is when you build a model, publish a model, you something called embedded resources, right? You pass it on as with the APK or with the application export as an embedded resources. And then while doing the embedded resources, you obfuscate the code, right? So obfuscation just makes everything like just the way any application you download on Google or whatever is this model is part of the resource, right? And then that's case one. So let's assume somebody breaks in, reverse engineer your APK and sees the model. He doesn't know the input, the output. Basically, what we see is just a bunch of code, because when you import the model, and I'm talking about coding now. When you import the model, there are floats, there are tensors that are used as inputs. You basically don't see. It's just like I train this model, I export one tiny file, and that file is what I make inference on. Basically, it's just like somebody picking a bunch of gibberish. So it's still safe.
Okay, thank you. And the last question is about, well, it sounds like this. Will it also be applicable to laptops, not only to mobile devices?
Yes, I'll take that. So
Okay.
we can deploy this model and be able to run it locally on x86, your laptop. So it's not just on mobile devices, if that answered the question. Yeah.
Ideally,
Okay.
the initial way is for you to run it on your laptop. It's open when you are coding, writing, developing models. You are running it on your computer. That is the norm of the day, right? So it's fine. Then sending it to edge device means like you are, instead of deploying it on your laptop, hosting on the cloud, and
Yeah.
then calling API calls. You just send it to your mobile, and then you can run
Directly.
locally without the internet on your mobile phone. That's the power of edge device. It brings everything close to you, so you don't need the
Yeah.
internet to open the application. I can even open it now. You don't
Yeah.
need the internet, so that's the power of it.
Yeah, just to buttress what I say, the purpose is when we talk about edge devices, I think one of the things that it has done for us is the fact that we can make inference on the device in real time. So what we built can be used directly on mobile, on anything. You could talk about any of the edge devices, but this was just an example for us to see that we can actually train a model, quantize it, and deploy it on this small device, a smartphone.
Okay, thank you. And I will provide it with the last two questions. Okay, a second, and we're gonna say it. Okay, copy and paste. All right, probably you are seeing this at that moment, those questions, but I will make it clear so that I will click this question which was answered, and I will highlight the new one. What is the status of neuromorphic chips and spike-based algorithm in such devices? Are there any solutions deployed in the edge devices that you are aware of using those technologies? Is there any research interest in those topics in the industry?
You want to take this?
Yeah, you can go for it if you.
Okay, so neuromorphic chips and spike base. I'm not really familiar with this statement. Yeah, but basically, let me just put it like this. Yeah, you have a project you want to do, right? So maybe you want to create a very basic one. I have an attire detector, right? You just want to create a mobile app. Uh, like I worked on a project before for detecting waste, right? So you open your phone and then you put the camera on, and then you will see like a bounding box around the object. This is real time on your phone, and then it tells you this is a paper or this is cardboard. So this you can do on your laptop using real-time feed or upload to Azure or the cloud, so cloud-based solution, which makes it easy. But the real essence of edge device here is that you're taking this model that can run on high computing space in the cloud, you quantize it, reduce it to a very low file, and then you send it locally to your device, to your Raspberry Pi, to your smartphone, to your or any chip Arduino Uno that is that has very low memory. So with this, you can still perform the same results, right? So now you're getting the camera feed directly from your mobile, making inference against the model, right? And then you're getting your results real time. So that's the whole essence of the edge device computing, right? So I don't for the neuromorphic chip and spike based algorithm, to be honest, I don't really know what that means. So I hope I answered your question in another way.
Okay, and the question, and the last question, I just highlighted
Okay.
this. Do you think you could solve this problem without this CNN?
Yes, we can. It is possible to deploy this model without using CNN, because there are also like some other models we could use, decision trees, random forest, and the likes, support vector machine. We could use all those things. We could use we could use LSTM as well, or recurrent neural network. So it's not just CNN. But that's why in my discussion, I mentioned that you need to know like the business requirements. What are we trying to solve? What kind of model we fit for this device constraint that we are trying to use for? And I think if you could answer those questions, it will determine or give you the right solution to know which of the model is suitable for you to use. So yes, we can use other model apart from CNN.
And one last, and also to buttress what my friend said, right? So you created a stock price detection algorithm. You built a stock price detection algorithm using XGB, and then you want to make inference locally on your phone. So I don't know if you've heard. You can check out ONX ONX,
Yeah, Onyx
ONX.
runtime. Yeah.
So this is like open neural network exchange, right? So developed by Microsoft and a lot of the big guys. So with this framework, you can develop algorithms from any with any framework, PyTorch, TensorFlow, XGB, do whatever you want, and then you use this runtime to generalize. So basically, you take whatever you did on the cloud or on your computer, pass it through ONSX, ONNX. I usually mix this up here. And then so you get an output which can be deployed to your edge device. So it's not just CNN. You can just build a stock price, whatever, and you want to locally deploy it on your mobile, you can do it also. So which makes it really fun.
Okay, I think we have it. Okay, so bravo, thank you. No more questions. Just being thankful for having you here during our Data Science Summit conference. We wish you all the best. Stay healthy and see you soon. Bye
Yeah.
bye.
Thank you.
Bye.
Thank
Thank you.
you.
The
Thank you.
pleasure is ours.
Bye.
Thank you.
Bye
Bye.
bye.
Bye.